Okay, welcome to the next video. This is 8.4 and 8.5. Let's keep, change, and flip. In order to use this strategy, boys and girls, you need to already understand how to multiply fractions and whole numbers. Hopefully, you've understood the last 3 lessons about dividing fractions. And we're going to use multiplication expressions containing fractions. This is a shortcut, but remember, it is extremely important to understand how to visualize your problems so that you can create an expression or write an expression. Then you can use a strategy, keep, change, flip. And I'll show you what I mean by that. In this lesson, we will obviously, as always, persevere in problem solving. I don't think we'll be using any tools during this lesson, but if you have tools at home you'd like to use, that's great. You might need to critique the reasoning of others if you decide to pause the video and evaluate the way that I've solved a problem. Of course, we will make use of structure. Definitely, this is going to be extremely important. And there is an opportunity for you to use models if that's helpful for you. So what exactly is the keep, change, flip? A lot of you have probably seen this on iReady already, and it's a really cool strategy. So let's say I have 1/8 divided by 6. Now, this is assuming that I already understand a word problem that would require me to set up an expression that looks like this. So a word problem that would require an expression set up this way might be that Matthew has 1/8 of a huge sheet cake and he wants to split that 1/8 of this huge sheet cake amongst 7 kids. So Matthew's going to take 1/8 of his sheet cake and divide it amongst 6 of his friends, not including himself. Well, he writes out this expression and now he wants to solve it. Well, he's going to keep the 1/8. He's going to change the sign to multiplication, and he's going to flip the divisor. Now he can solve. I hear your brain exploding. Now we know that each one of Matthew's friends will receive 1/48 of the whole cake. So Matthew had 1/8 of a cake. He split that 1/8 into 6 equal pieces. And then we want to know what fraction of the whole cake are his friends going to have. They're going to have 1/48. Let's try the next one. Now we can say maybe Susie has 6 whole cakes and she wants to cut them into 1/8 serving. So she's going to cut each cake into 8 pieces and each person is going to get 1. So she has to cut them into 1/8 pieces. The question is, how many pieces of cake that are this size, 1/8 servings, will each person get? We're going to use the same strategy. We're going to keep the 6. We're going to change the sign, and we're going to flip the divisor. Now we have 2 factors. Now we can multiply. 6 times 8 is 48. So there will be 48 1/8 size pieces of cake. Hopefully you see the difference. Let's try another one. Stephen runs 1/11 of a mile and he wants to do that over 4 days. Now I know Stephen can run much further than that. in one day, but he wants to run a total of 1/11 of a mile, and he's going to split that up. Here, notice the word split that up over 4 days. Well, we will keep the 1/11, change the sign to multiplication, flip that 4, and now we will say, oh, okay, Stephen will have run, or he will run 1/4 of a mile each day. And we could say each of 4 days. Let's do another one. Notice the strategy. We will keep the 4, change the sign, flip the fraction, and multiply. And remember, we place whole numbers over 1. This is going to be 44. Neat, isn't it? This is how we use multiplication to solve division problems containing fractions. So here's a problem. Stephen has 6 pieces of firewood. Okay. He cuts each piece into fourths. How many 1/4 size pieces of firewood does he have now? We need to model this, write an expression, and solve using multiplication. So he has 6 whole pieces of firewood. He wants to cut them into 1/4 pieces. How many 1/4 pieces of firewood will he have now? We're going to call that P because it's pieces of firewood. And we can show that here. 1, 2, 3, 4, 5, 6. And we're going to cut them into fourths. How many 1/4 size pieces do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24. Now, I've counted that I have 24 because we said to model, but I could also use my strategy, keep, change, flip. So I will keep the 6, change the sign, flip the fraction, and solve. But first, I need to place my whole number over 1. 6 times 4 is 24. And of course, we know that 24 over 1 really is just 24. So we don't really have to put the 24 over. We know it's a whole number because they're asking us how many 1/4 size pieces will there be. So there will be 24 1/4 size pieces. Okay, let's try another one. If you'd like to, you can pause the video and then you can use the we do and the you do on your own. Layla wants to read half of her book in 3 days. How much of the book should she read each day? And this is assuming that she's going to read the same amount each day. So she wants to read half of a book in 3 days. And we want to know how much should she read each day. So we're dividing her half of the book into 3 different days. So how do we model that? Here is split the whole book in half. Oh, wait, I can. So we split the book in half, and she wants to split that half into 3. Well, we've learned from our previous lessons that we just go ahead and split the whole thing because the question is about how much of the whole will she have read. okay? But we're going to use our strategy, keep, change, flip. 1/2 times oopsie, 1/2, keep the 1/2, change the sign, and flip the 3. She will have read 1/6 of the book each day. So here is the first day, the second day, and the third day. And I can even label those for you. Day 1, day 2, day. Each day she will read 1/6. She will read 1/6 of her book. Oh, that's not right. 1/6 of her book each day. And let's add some flair. She will read 1/6 of her book each day because 1/2 divided by 3 equals, what did we learn? Change flip. 1/2 times 1/3, which equals 1/6. Now I'm showing my reader that I understand exactly what I'm doing. Finally, try this problem on your own. Remember the 3 things that you must do. You must model, write an expression, and solve using multiplication. Go ahead and pause the video, and I'll come back with the answer. Okay, let's check your answer. Some of you might be thinking, oh man, I got this wrong. Maybe you didn't make the connection between yesterday's lesson or the previous lesson and this lesson. Remember that division models fractions, or fractions model division. So let's take a look. We have 3 pizzas. 1, 2, 3. And the 3 pizzas were shared by 5 teachers. That's what I meant by visualizing the problem. You have to be able to set up your problem correctly. It's not 5 pizzas being shared by 3 people. It's 5 people sharing 3 pizzas. That means we have to take 3 pizzas and divide them or separate them out equally for 5 people. So that means we're looking at 3 divided by 5. We didn't really even have to do anything because when we say 3 divided by 5, that's a fraction. So how much will each person receive? Each person or each teacher will receive 3/5. Each teacher will get 3/5 of pizza or 3/5 pizza because 3 divided by 5 equals 3. You could have also said, or you will get 3 1/5 size pieces. Why can we say that? Because each one of these pieces is a 5th. Does that make sense? Great. Take a look at the scale, find out where you are. Hopefully you're a 3 or a 4, and write down the questions that you have and be as specific as possible. Thanks for watching.